All right, we're going to continue talking about systems, but now we're going to talk about systems that have three variables. Okay, so you just talked about how to solve a system of two equations with two variables. We looked into graphing and then substitution or elimination. You could have learned both, but you had to only learn one. But you had to learn how to do graphing. Now we're going to look into how to do systems that have three equations with three variables. So now instead of x and y, we're going to have x, y, and z. When you have a system of two equations with two variables, you are on your xy coordinate plane. You're on a two-dimensional surface. But with three, you're going to think of three-dimensional. So now you're going to think about like how we live and not on a sheet of paper. So with that in mind, first things first is we can't solve these by graphing. There's not a way to three-dimensionally graph these systems. These systems also, these equations, because they're three variables, are not a line, they're a plane. So it's like a wall or the floor or this piece of paper is what that equation forms. So you have our traditional XY axes that go the side to side and up and down, but you also have the Z axis, which is going to like go through your paper. So kind of like, it's hard to show you here in the video, but like through the paper. So we have X, Y, and Z. So, like I said, it is a plane and not a line. So when we're looking at our system, instead of where the lines intersect, it's where the planes intersect. So I have some examples here, and I'll give you some real life things to think about so that you can either visualize it or look around the room to actually see what I'm talking about. So here, and I know it's kind of hard to see, there are three planes here. So there's a plane, there's this plane here, and then this kind of darker one. They all intersect right here at that location, right? That is a one solution system of three equations where all three planes intersect. If you look around the room and find two walls that meet, and they also meet with the ceiling, that corner where those three things meet is an example of a system that has three equations, and has a one solution. Their one solution is that corner piece between the two walls and up at the ceiling. If that's kind of hard for you to understand visually by yourself without me really pointing it to you, let me know. Pause this video. I will physically show you what I'm talking about, because I know it's easier to see that than it is for me to just describe it in words. Next, there are infinite solutions. That is this graph here. So that is if your three planes intersect at a line. That would make infinite solutions. There's not an example around the room that I can see for you to see. But if you just see how these are, where you have like, if you were to have three walls that intersect, it would be that middle part of your wall, like this part here. Okay, that one is definitely harder to visually see, especially around my room. There's not really a place to officially see that. There are three types of no solutions, what they would look like visually. No solution is if not all three systems intersect at the same place. So this first one, I have some intersections, but it's only these two planes intersecting or these two planes intersecting. I never have all three intersecting at the same time. So this is like if you were to have, if your room were a triangle instead of more rectangular shape, that would be a no solution three variable equation or system. One that you could visually see here, this is like the ceiling and the floor and any wall around my room. The ceiling and the floor are never going to intersect. The wall intersects with the ceiling and with the floor, but not all three things intersect. So that's another no solution. And then this would be like the ceiling, my floor, and the floor to the first floor, right? You have 3 different levels and none of those intersect. So in order to have a solution, all 3 have to intersect together at one point. All right, that is the only way to have a single one solution to a 3 variable equation system. It's infinite if it forms a line, and it's no solution if only 2 or fewer of them intersect. A one solution system intersects at a single point, and we are going to put it in order alphabetically, X, Y, Z. So when you solve your system here in a moment, you're always going to, when you're done, put it like it's a point, but your point is not going to be an X, Y, Z coordinate point. You put them in order alphabetically, just like we do with a coordinate point. We put X and then Y. If your equation has letters other than X, Y, and Z, maybe you have A, B, and C. You're always going to put them in order. Put A and then B and then C. All right. Like I said before, infinite is going to intersect at a line, and no solution is going to not intersect for all 3. 2 of them might, but there's not going to be a solution to the entire system. All right. We are not going to solve these by graphing, like I said. We are going to focus on elimination or substitution. So, this point right here, I need you to make a choice. Did you like elimination or substitution better? Keeping in mind that you're allowed to change your mind. I also will let you know that in general, this lesson tends to be easier for elimination. Substitution is going to have a lot more fractions to deal with, and that can definitely make this lesson more complicated, and it's already going to be complicated. So in whatever you did in your last lesson, if you chose substitution, you're allowed to choose elimination here, or vice versa. If you want to try substitution here, it's fine. It doesn't matter to me. It matters based on what you are better at understanding. So make a choice. Do you want to try to learn elimination or substitution? And then watch that video only. And then as long as it makes at least somewhat sense and you're good to try stuff, maybe you need my help. But if you watch the elimination video, then start working on your problem solving with elimination. And do not watch the substitution video. Or maybe you only watch the substitution video, start doing your problems, and you don't watch the elimination video. The only reason you should watch the other video is if you watch the first one and you're like, this doesn't really make sense, let me try the other one. And you're allowed to do that. I'm just saying you do not have to, and you probably shouldn't watch both videos. Pick one method, elimination or substitution, watch that video, and go.